Hello, this is Noah Lee, and this is my submission for CSC313 graphics for, I believe, this is Project 6 on cell shading. I'll go ahead and start up the program and show off what we were able to do. This is the best that we were able to do. Unfortunately, it's not quite a perfect line around the edge. You can see some clipping on some of the faces here, and the edge does, I believe, break on some of the corners up on the top. If I quickly change the color here to something that's going to be a bit more visible, if I change this to red, we can see the edge a bit more clearly. I should go ahead and bump up the thickness of the line here, something that's going to be even more visible. That up to 30. We can see where the cell shading appears. We see a little bit of a gap here on the bottom and a much larger one here. I can go ahead and discuss where and why that happens. So here is my code. Um, Here is the code itself, and I can go ahead and show off what was changed. The only thing that was changed here was to pull in a normal value using the predefined calculate face normal function. This takes the entire model along with the face that we're targeting. This face is determined by the loop that we did use for drawing the vertexes of the highlights on all the lines. We then define ranges for x, z, and y. In this case, technically speaking, x and y ranges are not used. However, I did declare them just for the ability to test. Then we check the normal value for the face itself to see what direction it's pointing in. If it is within or outside of a particular range that we define, we go ahead and draw it. Otherwise, we do not draw it. Doing this after declaring the is perpendicular, we move into the normal drawing function to check over to draw the individual lines on all of the vertex on the corners of the vertex to display this. Then print out the shape itself. If I change our lines back down to something a bit more reasonable, and go ahead and run this code. I can describe a little bit how this code works. So what we do is we take the normal. The normal is the average of all of the normal vectors on the corner of each face. I'll go ahead and use this face here as an example. We take the normal of the vectors, of the vertices, then average them to get the direction, basically like the plane that is being projected out of the center of the face. This defines what the vector is, a vector being a trio of coordinates that define a position in 3D space. That position is where the face is basically pointing. We use this vector to define a range that we accept or deny the drawing of the vertice edges. This is why we have gaps in some places and why we have the entirety of a given face always drawn in or not drawn. I can show if I decrease the range that we use here. So if I say instead a range of 0.8, we can see that instead only faces near the center of this corner of the sphere are not rendered, meaning that these faces, the normal that comes out of them is either is greater than 0.8 in direction to the in perspective to the camera, meaning that since they are out of that range, we do not render the edges on their faces. However, since this and this face are within that range, we render this edge and this edge. Again, not this one because we're not rendering the faces on, the edge on this face. So we get this face is within the normal range, so we do draw its corner of its edges, but not this one. And then simply by messing around and finding a more precise value, I was able to come with a Z range of 0.94 that will give a somewhat approximate rendering of cell shading. Again, this is being rendered in red just for so it's a little bit more visible. Go ahead and change this back to black to get a somewhat approximation of our cell shading. And then I did add a small thing on the bottom. When we create the model, I just printed out our vertices, faces, and normal size, just to be able to use this for testing to see what was being printed and how large our arrays were. Okay, thank you very much. That's everything. This is not a quite perfect, but a not quite perfect implementation of cell shading, but is a close enough approximation for what I was able to figure out with a relatively simple implementation. Okay, thank you very much. Bye.